Hey guys, this is Nishant and I'm doing a video for my physics class. I'm sorry about the noise at the background. It's because of my AC. Anyways, in this problem, we're gonna find the momentum, or let's say the change in momentum of a star. Now, according to the problem, we have two stars and they are revolving around each other. Now, obviously, there is a change of momentum at a certain instance where the time is 1000 seconds. Some of the values are given, like the mass, position, momentum of both the stars are given in a vector form. Now our goal is to find the momentum of the first star after a certain interval of time, which is 9000 seconds. Now what do we know according to momentum principle? That the force is equal to change in momentum divided by the change in time. So we can directly calculate the change in time, which will be 9000 minus 1000, which will give 8000 seconds. Now we need to find the distance between the stars, and the distance between the stars can be calculated through the position. If we subtract one position from the other and then take the square root and then square each of the vector components, we're going to get the distance between the stars. Now after we get the distance between the stars, we need to find the net force acting on star. So the net force acting on the star, Fnet, is equal to negative of gravitational force times mass of each of the stars times the unit vector of the distance between the stars. So we just directly plug in the values, which will be, for G it's going to be 6.67 times 10 to the negative 11, and then for mass it's already given to us, and the unit vector stays the same, and then we have the distance, which we already calculated from here. And after we plug it in to find the unit vector, we just need to take this resultant vector and then divide it by the distance, or let's say the magnitude of this same resultant vector. After we do this, we're gonna get the net force acting on star 1, which will be 1.4 times 10 to the 33, and then the y component is 4.7, negative 4.7 times 10 to the 32, and the z component is negative 7 times 10 to the 32 Newton. Now after this, we need to find the momentum, and according to momentum principle, we know that the net force acting on an object is equal to the change in momentum divided by the change in time. So we already found our, in this case we already found our net force acting on star 1, and the question already gives us the initial momentum, and it also gives us the time, the change in time. So if we plug in all the values, then the only thing we need to find is the final momentum. Now we plug in all the values, the 8000 goes here, and then we multiply, and then this comes this side, the right hand side comes to the left hand side, and then we add it together, and then we're gonna get our final momentum, which will be 8.12 times 10 to the 37, negative 8.38 into 10 to the 37, 1.44 into 10 to the 37 Newton second. So that's it. I wanted to make this video as short as possible, that's why I went over it really quickly. If you guys have any questions or comments, you can post it under the video. I'll be happy to answer all of your questions. Thank you.